Okay, so last day we looked at two types of conversions. Conversions within the metric system, the SI system, and conversions within the imperial system, right? But we just basically focused on the metric system. So today I want to look a little bit more at that imperial system. Okay, so just flip open to the example on page 6. We did that with the window. Okay, so I'm just going to pick one of the measurements. I want to change 78 inches into feet. Okay, so I want to change 78 inches into feet. All right, so first thing I do, I write down which unit I want on the top of it. So in this case, what do I want on top? Feet on top. I want to get rid of the one that's on the bottom, which is the inches, correct? Okay, because those, when they divide, will cancel out. And what's my ratio of feet to inches? 1 foot to 12 inches. Excellent work. Here we go, 1 foot to 12 inches. And because the 12's on the bottom, what do I do with it? Excellent, good. Okay, so 78 divided by 12. All right, and that works out to 6.5. Okay, so everything's good there, right? Do we have any difficulty with that? No? Okay, excellent. So today's lesson, excuse me, is 1.3. So I'm just going to go into it. Now I will tell you, basically this is our second class, so I want to be done to the end of 1.2 at the end of today. On to 1.3 tomorrow. It's kind of how I want to work it. All right, so you'll have lots of time in class to do this. The only thing is that, like I said, I'm not going to give you homework on daily assignments. I'm not checking your work. Okay? If you're not done, it'll show up at the test date. All right? So it's up to you just to continue on. Check your answers in the back of the book. If you got something wrong, then I want to know about it. All right? Any errors you make, I want to know about so that I can help you, because I guarantee 4 or 5 others made the same error. All right? So now, the main and most important ratio we need to know when it comes to using these two particular conversions is these guys right here. 1 inch is equivalent to 2.54 centimeters. That's the most important conversion that you want to work with. Because once we get out of this part, we start rounding a lot. So what I mean is, if I look at 1 foot is equivalent to 0.3048 meters. Well, that one's not bad because I have 4 decimal places. But as I get larger, I get less and less accurate to it. So anytime you want to convert from metric to imperial or imperial to metric, we probably want to get as close to that or use that as often as we can. Okay? It's just to make life simpler and get you more accurate answers. All right? Okay? Now, let's have a look at a question here on page 10. I love this question, actually, because it gives us a lot of conversions in one simple thing. The land speed record is the fastest speed achieved on land by any wheeled vehicle. A turbofan-powered car holds the current record. The car reached a speed of 766.609 miles an hour for 1 mile, breaking the sound barrier. So a turbofan-blown car reached a speed of 766.609 miles per hour. Okay, now I may be misspeaking here. I could probably look it up pretty quick, but I think this has been recently broken in the last year or two. This land speed record. So we'll have a look at it in a second and see. Okay, now it says express the statement about the car's speed in kilometers per hour. So I want to convert miles per hour to kilometers per hour. So I don't have to mess with the time. The time stays as hours, so that makes it a lot easier. But I need to change miles to kilometers. So I'm going to put kilometers on top, miles on the bottom, okay? And I'm going to flip back to the page before, and I'm going to use one of those two ratios. So somebody give me the ratio of kilometers to miles. 1 kilometer is how many miles?
0.6214.
Very good. 0.6214 miles. Okay? And because it's on the bottom, what am I going to do with it? I'm going to divide it. That's right. So let's take this and let's divide it. 766.609 divided by 0.6214. So you're going to use your calculators here. It's necessary that you have one. All right? And when we're working on the board, I like to see that your calculators are always out. Okay? And the reason that is then I know that you're engaged with me. Okay? So how many kilometers per hour is this? Jax, you got that down?
1,233.680.
233?
1,233.
Yeah.
0.6804.
04. Well done, Jax. Kilometers per hour. We all get that?
Yes.
Excellent. That's fairly quick, isn't it? It's fairly quick. 133.6804 kilometers per hour. All right? Does anybody know what the sound barrier is? What's the speed of the sound barrier? You guys know? It is. It's 1,000 kilometers an hour. That's where the sound barrier is going to break. So he went way over it. Way over it. Okay? All right. Now, let's have a look here at the next question. So again, we're going to be doing some converting here. Oh, sorry. Are we okay with that? Anybody have questions? And it's simple. As long as you have those, and you will be. You will have all of the ratios given to you. So as long as you can apply them, that's all I need. All right? I'm not asking you to memorize them. You have those sheets. They'll be given to you, those charts. And as long as you can apply them, that's great. Okay? All right, at 15 degrees Celsius, the speed of sound is 1,116 feet per second. Okay, so let's make sure we got that right, Emma. It says 1,116. And one we already here. Okay, 16 feet per second. Okay, that's what they say the sound barrier is. The speed is given as a measurement called Mach 1. Excuse me. How many miles per hour above Mach 1 was the car's top speed and how many kilometers per hour? Okay. So I want to change this guy into miles per hour. So what's the first thing that you see I'm going to have to change?
The time.
The time? Seconds to hours. Right? There's for sure. And then what's the other thing? Feet to miles. Awesome. Okay. So we'll work with time first because that's what somebody said. Now, this is one of the measurements I am going to ask you to remember. Okay? Because I think we use it so much. All right? So I need to get the seconds is on the bottom and I need to change it to hours on the bottom. So I write my hours down there and I put my seconds up here. Can somebody give me the ratio of seconds to hours? How many seconds are in an hour?
3,600.
Awesome. Right on. Not worried about you remembering it then. 3,600, right? 60 seconds and 60 minutes makes 3,600. Okay. So that's going to get me hours on the bottom, right? Now I could put that into my calculator and then I could redo it, I could continue on. But because we're in this math, I think you should be able to do a couple things at a time. So now what I want to do, sorry, excuse me. Now what I want to do is I'm going to change that feet into miles. Can you look at one of those charts and see if we get told how many feet are in a mile? I believe it's on your
3,280.84.
right on. Okay, what page are you on, Brandon?
9.
Okay, so everybody just has to flip it over, one page. And it says 1 mile. Nope. What'd you say? Sorry.
Oh, that was kilometers to feet. Never mind.
Right. Okay. So you're on the right track. Okay. Go back one section. Keep going back. We're doing Imperial now, right? So it'd be nice to have this all in one. I'm going to photocopy a sheet for you today to have this all in one. Okay. So take a look at page 5 now. 1 mile is how many feet?
5,280.
Beautiful. Okay, so I want mile on top here, right? And feet on the bottom. And 1 mile is 5,280 feet. Like that. Okay so far? Yeah? Right on. All right. So my feet are going to cancel out. Now, somebody, put up your hand if you think you know how to punch this into your calculator. Go ahead.
1,116 times 3,600 divided by 5,280.
Wonderful. Good job, Lily. Okay? 1,116 times 3,600 divided by 5,280. Somebody got an answer for me.
760.9.
16 or 60?
760.6.9.
Like that?
Yeah.
0.9. Thank you. Okay. Now, miles per hour. Now, I have to apologize. Number one, I'm hard of hearing because I'm old. But I have a fan above me. So if I can't hear you, I'm going to ask you just to be a little bit louder, okay? So 760.9 miles an hour. How much faster did he go, approximately?
500.
How much faster did he go over the Mach 1, the sound barrier?
6.
About 6 miles an hour. That's right.
Yeah, always.
Okay?
Oh,
Is it
yeah.
766.609 miles per hour is how fast he drove, and that's the sound barrier right there. Okay? So far, so good? All right. Now I'm going to go back through this again. Now I could use this guy here, and I could convert miles to kilometers, and I'm probably going to get pretty close to the right answer. But as you notice, I have started to round already, right? So that means that my answer is going to get further and further off of what it should be. So I'm going to go back and start that again. And this time, instead of using, seconds cancels, right? Instead of using miles to feet, I'm going to use kilometers to feet. And how many feet were in 1 kilometer? 3,280.84 feet. All right. Okay. So now 1,116 times 3,600 divided by 3,280.84.
1,224.56.
All right. We're a little bit off, Emma. I was as off as you were. I thought the same. I thought it was around 1,000 kilometers an hour. It is not. It's 1,224.56 kilometers per hour. So how much faster did that turbofan vehicle run? Approximately what?
9.
9 kilometers an hour faster, right? Okay? This is the type of measurement stuff that we will do a lot of. Because when you start getting into grade 10 science, you start doing some physics, you start doing some chemistry, you do a lot of conversions like this. Okay? So if we get the base right now, we'll be off and running. You won't have any issues in your science class when it comes to converting units. Okay? That essentially is all I have to show you right now. All right? Would you go back to the work that you did on Monday, so that 1.1, or sorry, Tuesday, your 1.1? And if you started 1.2 and you got any questions on there. So if you have a question, put up your hand, give me the page number and the question number, and we'll go right to it. Go ahead, Emma.
Number 5.
Page 3, number 5. All right. This was asked last year as well. Okay. So, a running oval with each end in the shape of a semicircle has the dimensions as shown. Stefan runs the inner track and Rachel runs the outer track. The distance between the tracks is 10 decameters. Press the difference in meters in the distances that the boys run for one lap. Show your reasoning. Okay, so the first thing I'm going to do is, basically I've got a rectangle here, right? In the middle of the track. And then I have two semicircles there, right? Now, I'm going to run equivalent to the whole way around the circle. Would you agree?
Yeah.
Okay. So I'm going to concentrate on the inside of the track first. All right? So the inside of the track, I'm going to look at my perimeter then. And do we know how to find the perimeter of a circle? I told somebody the other day, what is it?
No, that's 5 times diameter.
Not squared, you're right, the first.
2 pi r.
2 pi r is right, or you said it as well.
5 times, or yeah, 5 times
Pi what?
times diameter.
Pi times diameter. Pi r squared is the area. Pi d and 2 pi r is the circumference. Okay? And we see that the diameter is 50. So let's use that one. I'm not a big fan of it. I always use 2 pi r because when we get into other classes, it's way easier to use it, and you have to use it more often. But we'll use it this time. So pi times d. So that's going to give me the perimeter of the circles. I also have to get this distance here and this distance down here. Right? Because he's also going to run those distances. This I don't need. So what I want to do then is I want to add on those two distances. So what? Excuse me. What's the length to the circle there, or to the where they start?
150.
150. And I have two of those lengths. Would you agree? Okay. So let's find out the guy that ran on the inside of the track. Let's find out how far he ran. Got it?
457 meters. That's correct.
Yeah, that's.
Yeah, right on the nose?
Yeah.
Okay, I'm going to say no, but we'll use it anyways. All right? Because I have pi, which is 3.1415, and so on, right? So you would have a decimal in there, but we'll worry about decimals after. Okay, so pi d plus the two lengths gives me that, right? Okay? The second guy. What is the diameter of his circle?
52 meters.
52 meters?
Yeah.
Are we sure?
You add
Yeah.
2 decimeters to it, and that's
And what is a decimeter?
10 decimeters is 1 meter.
1 meter.
10 decimeters is 1 meter,
So you got
and you have 2. Well done. Very well done. Okay, so this part right here, it says that that length right there is 1 decimeter, which is, or no, 10 decimeters. Doesn't it say 10?
Yeah.
10 decimeters, which is equivalent to 1 meter. So that adds on 1 meter here and 1 meter here. So the diameter then is 52. Does that make sense? Yeah? Does this change? Does that straightaway stretch change? No. Only the cornering changes. So how far does he run then?
463.28 meters.
All done. Are you okay?
Yeah.
All right. Was the decimeter conversion the problem?
No.
Or are you
not
just
that
trying to
far.
understand the question itself?
Yeah.
Okay. Right on. Anybody else is good with that question then? All right. Other questions? Other questions?
Number 7.
What page?
4.
Okay. So the first thing you have to do is measure that 15 kilometers and see how many centimeters that is. And what do you get?
1.55 centimeters.
1.5 centimeters is 1 kilometer? What I heard over here? 15 kilometers, right. Okay. Now, it says to estimate, I don't like estimating names, determine the length and the width of the park using the scale. So basically what I want you to do is I want you to measure, let's start by measuring this part of the park right here. Okay? What did you get?
9 centimeters.
Awesome. Okay? And then let's go across here. What was that measurement?
5.5, I believe.
We agree?
Yeah.
5.5?
Yeah.
Perfect. 5.5 centimeters. Okay? And then measure down here. Just to where it starts to get all
6.
6 centimeters here. Now I want you to measure this part right here. Just, it's an approximation. Obviously that's where the estimation comes in.
3.2.
Okay? And then measure from here to here.
3.9.
Okay, great. Somebody, before I go any further, tell me how you could measure that more accurately.
Draw a line.
What do you mean?
You draw a line from the one point to the next point.
Okay, but I'm still getting a straight line distance, right?
Yeah.
Tell me how I could do it, Deacon, if I want to get the actual, like the very exact measurement there. What would you do? Just wait 1 second. Go ahead.
Wrap a string around it.
Yeah.
Measure the string.
What if I did that? What if I took a shoelace, or a piece of string,
Around the problem.
and zigzagged it all the way down there, and then measured the length of the string after?
I guess, yeah.
You can do that, right?
Yep.
Okay? No, I'm not telling you to do that. All right? Because that's time, and I don't want anybody taking their shoes off. It's too smelly at this time of day. Okay? So you could do that with a string. And then we can measure it. All right? So now that I have this, let's add this all up. 9 and 5.5 is?
14.
14.5. 14.5 and 6 is? 20.5. Add 3.2.
23, 27,
23.7. Add 3.9.
27.4.
What is it?
27.4.
27.4. She's too quick on the draw. Well done. So I got that, right? Now let's set up the ratio that we did up here. 15 kilometers to 1.5 centimeters. Okay? So you would times by 15, divide by 1.5, and you get as close to the perimeter of the park as you could.
Okay.
Does that make sense?
Yeah.
All right, anybody else? I know there's a couple of you that were looking at that question yesterday. Is that all right? That'll work out for everybody? Awesome. Yes, Emma.
Question 6 on page 3.
Question
That is
6
the
on page
one
3. Oh, that flea. All right. The jumping flea. Did you get it, Emma?
Yeah.
Awesome. Okay. Okay. A grass flea can leap a distance of 350 times its length in a single jump. What is the length of a grass flea that covered a distance of 70 meters in 500 jumps? Okay. Anybody want to start me off on this?
70 meters divided by 500.
Beautiful. That's an awesome way to start. Let's find out how far he gets in one jump. Let's find out how far he gets in one jump.
0.14.
0.14, is that what you said?
Yeah.
Awesome, okay, 0.14 meters, correct?
Yep.
All right, so now it says that is 350 times the length of the fleet.
So when you divide it by 0.14.
I agree with you. I would divide that by 350. Okay? So let's divide this number by 350.
0.0004.
0.0004. That's meters, right?
Yeah.
Okay? We got the right answer so far. But that's a pretty small number, isn't it?
Yeah.
Okay, so what would you measure it in, Eli? What would you change it to?
Centimeters or
Centimeters?
Centimeters or millimeters would be good.
Okay, so which one would you like to do first?
I'll try centimeters first.
Okay, so what do I do with this number to get it to centimeters?
Multiply it by 100.
Okay, so let's times this bad boy by 100. And what do I get? Well, let's just move the decimal twice. Is that right? Okay, so I've got 0.04 centimeters. Okay, so that's better.
But you could go a bit more down.
Okay.
0.4 millimeters.
Okay, so what do I times this by to get to millimeters?
10.
By 10. So I'm going to end up with
0.4.
0.4 millimeters. Still a pretty small fleet. But that makes sense, doesn't it? Right? Okay. You all right with that? Okay. What part was causing you grief?
Well, the beginning, but I wasn't sure if I began.
Started the question right? Okay, you did. You started exactly right. Okay, good work. All right. What I want you to do then is I'd like to see it done to the end of 1.2. And again, it's not necessary that you have to do every single question. If you feel like you're falling behind, do every second question, then go back and fill the ones in after. All right? They're all just more practice, more practice. But sometimes we do too many of them and we get fallen behind in our work. I don't want you to do that. Okay? So 1.2, that's basically page 7 and 8. And if you finished up there, you can start in on page 10 and 11. All right? Okay, good stuff. Go at it then.
How do you do that?